Hey guys, welcome to our video. As you can see, I'm in the corner. What up? Whoops, over here. So anyways, I'll be recording. I buttoned all the way up so I look really fancy and nice for the video, and I even did my hair. So I think we're doing pretty good. Alright, let's get to it. We got a lot to talk about. So let's get started. I'm going to switch over my colors. Anything I write, make sure you write down. Alright, first we're going to start out with the fundamental counting principle. Okay? All this does is just tell me the number of ways an event can occur. Okay, so it just tells me the ways that I can have an event. We actually talked about this one in class the other day. So rolling 2 dice. Okay, well, what are the possibilities of rolling 1 dice? I have 6 options, 1 through 6, and then I also have 6 options for the second dice. So there's 2 dice. All I have to do is multiply them together, and that tells me all the events that can occur. When I roll 2 dice, I can have 36 total things. And we saw this in our video. So that one's pretty simple. The fundamental counting principle is really just multiplying the number of things that we have. Okay? Alright, example 2. Mr. Smith can watch 1 Star Wars movie, 1 Indiana Jones, that's what IJ stands for, Indiana Jones, 1 Lord of the Rings movie, and 1 Lego movie tonight. How many possible outcomes do I have? Okay, well, first of all, you had to realize there's 7 Star Wars movies. I think there's 4 Indiana Jones movies, and I'm pretty sure there's only 3. I don't know if they made the second one a 2-part, but I think there's only 3 Lord of the Rings movies. And as far as I'm concerned, there's only really 1 Lego movie right now. Okay? So all I have to do is, since I'm only watching 1 of each, I just have to go ahead and multiply each of these numbers together. And that's going to tell me the total amount of outcomes I could have, right? 7 different Star Wars movies, that's 7 different options. 4 different Indiana Jones movies, 4 different options. 3 different Lord of the Rings movies, 3 different options. And only 1 option for the Lego movie. So all I have to do is multiply those together. I have my calculator right here. I'm going to go ahead and multiply. You get 7 times 4 times 3 times 1. Enter, and we get 84 different possibilities for my viewing pleasure tonight. Yes! Okay? Yes. Alright, moving on. Factorials. Okay? Factorials are interesting. Okay? This should be something you should look for on your calculator. It might be under probability. We'll talk about it in class. But basically, factorials are multiplying natural numbers in descending order. Okay? So they're denoted with this factorial. So how would I do 3 factorial? Well, I just take the number I see and then I multiply it by its next descending value. All the way until I get to 1. I stop at 1. If I go to 0, it means everything's going to go to 0. So all I have to do to evaluate this is 3 times 2 times 1. You can also do this in your calculator if you know where the factorial button is, and it's pretty cool. Okay, I'm going to see if I can show it to you on here. I don't think I can. Do you see that? 3 factorial is 6? That's awesome. Okay, so again, we proved it on the calculator, but 3 times 2 is 6, times 1 is 6, so we know that this is 6. Sometimes we're getting in fractions, and we're going to see this. And I could write this out as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over. Well, 7 factorial is going to be 7 times 6 times 5 times 4 times 3 times 2 times 1. What do you guys notice here? You should notice that the 7, 6, 5, 4, 3, 2, 1 are going to cancel out. Okay, so I should be able to cancel these out, and whoop, 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 and I should just be left with the answer of 8. Okay, and I'm going to see if I can do that on my calculator real quick. Let's see, 8 factorial divided by, you should try this too, 7 factorial, and I get 8. Cool. So do you see it? 8 factorial, 7 factorial, and then I get the value of 8. Okay? Moving on. Okay, next page. Okay, here's where we come to the juicy good stuff. Permutation and combination. I'm going to do a very basic generalization of these because we're going to talk about them more in class. But if you can remember anything from this video, remember this. Order matters for permutations. A lot of times people will use permutation, think of position. Okay, so position when you're thinking of permutation. Order matters. What position are you in? When we think of combinations, we should think of order doesn't matter. Okay, I don't care what order I have. Okay, now the mathematics behind how we do this is a little bit more complicated. We're going to talk about that in class. So right now we're just going to talk about how to actually do this. Okay, example 1. How many ways to arrange a 3-combo lock? Alright, we can do this. We basically want to use this thing called NPR. Okay, now NPR actually stands for something using factorials, and again we'll talk about that in class. But what we can do is we can actually find that on our calculator. Okay, and the NPR button is going to help us. What we have to know is what the N and the R is. So here's what the N means and here's what the R means. N means the total number of objects, okay, and R means the total number of objects to use. Okay, well, we got to think about this for a second. What are the total number of objects? So I'm talking about arranging a combo lock. Okay, and how many numbers could I pick for each number? Well, I'm thinking 10. We got 0 through 9, right? So the total number for me is probably going to be 10 different numbers. I can get 0 through 9 to pick. Okay. The number of objects to use. Well, how many objects am I going to use? Well, I'm only going to pick 3. Okay. And I'm saying order matters here, so I'm not going to do anything weird or anything like that. So this would be NPR. 10 choose, or 10 pick 3. Okay? So all I have to do is use my calculator. Now if you have this on your calculator, great. Go ahead and find it. If you don't, you need to find it. Okay? And if I do this, boom, there's my 10 NPR. I get 720. Okay? This is where order matters. Okay? For example, 332 and 323 are actually different. Okay? In combinations, those would be the same. So I could have picked 332 and I could also pick 323. Notice they're made up the same numbers, but order is different, so I'd count both of those. That's why I get actually a pretty large number. Okay. What if I'm okay with repeating? We can take a look at that one as well. So let's go ahead and look at our next problem. And it says arrange 3 pool balls out of 16. Okay, we can do that. Here's a key word to us to let us know we're probably going to be doing permutations. Arranging usually means order is important. Okay, so if you arrange something, you want to put it in order. Alright, so again, how many is the total amount I have? 16 NPR out of 3. Okay, again, using our trusty rusty calculator, we get 16 probability NPR and 3. Plug in our calculator, and oh my gosh, look at all those different combinations. 16 NPR, we get 3,360. Okay, different possibilities. Again, order matters here. The way I put them in really does matter. Now let's take a look over on this side. Whoop. Okay, over here, order doesn't matter. Okay, so if I did 332 and 323, they would be the same. So if I'm to choose 3 pool balls out of 16, I'm going to do, whoops, sorry, that is not what I'm going to do. I'm going to do 16, that's still the total number of objects, and I'm going to pick, not pick this time, I'm going to choose 3. Okay, again, I'm going to put this in my calculator. You're going to notice the numbers should be a lot smaller. Okay, the numbers should be smaller because I don't care about order, so I'm not going to double count things. Okay. Alright, so this time I'm not double counting things. So let's go ahead and show that up there. 16 NCR3 is 560. Same story, the only difference here is 1 order matters and 2 order doesn't matter. Okay. Here's a prime example. We did this one in class. I'm going to do one final one. Okay, we said toss 3 coins, right? We said toss 3 coins. Okay, and what's the probability we're going to get heads, okay, on 2 of the coins, or tails, right? So we could actually figure out what we have. So we have 3 coins, and we have basically two options, heads, right, or tails. Okay, so 2 options, heads or tails, and we have 3 coins. Okay, so total number of objects I have is 3 coins, and we want to see the probability of 2, I think. Let me just check that real quick. No, I think I made a mistake on that one. Let's go ahead. Let's scratch that one for now. I apologize. I don't want to get to that yet. We'll get to that soon, maybe in class. All right. I think we're good. Again, what do we want to remember? Combinations, order doesn't matter. We're usually going to get a smaller number. Permutation, order does matter. We're usually going to end up with a larger number. Okay? Peace. We out. I don't know where to stop. I don't know how to stop this thing. Where do I stop? Where is the stop button? Where is it? Is it here?